Good morning, everyone. Today we'll look into one program. By the end of this video, you will find and you'll solve the problem using the priority queue. The problem is kth largest element. Find the kth largest element in the given array. Here the given array is 10, 100, 20, 90, and 80. In this, find the kth largest element. That kth is to second, third, or fourth, and fifth, anything. And I have given here the input as second largest element. The second largest element is 90. I'm getting as an output as 90. Here 100 is the highest and the 90 is the second. This is the second highest element. Now we will look into the code how to solve this one. Suppose if we take as input as 100, 10, 100, 20, 90 and 80. Here uh, here we need to find the kth largest element. Suppose if we take the second largest element, then 90 we should get. To solve this for the third largest element is 80. To solve this problem, we have two approaches. First one is sort this array and find the index of this second largest element. After sorting, the array will be 100, 90, 80, 20 and 10. Suppose I want the second largest element, then index is second largest element, then index 2 minus 1 is equal to 1. In the index 1 we have the second largest element. This approach, it will take the n into log n time, and the if the array size is more big, it is time consuming. To overcome this issue, we are using the priority queue. This priority queue is another data structure. Its main purpose is it store the data based on the priority of the value. Okay. In Java, we have priority queue two types: minimum priority queue and maximum priority queue. Means minimum heap and maximum heap. Suppose if you have the input array 10, 100, 20, 90 and 80, and if we added these values to the priority queue and check the size of the priority queue. If the size of the priority queue is greater than the our target element, second largest element, that means size 2. The priority queue is greater than 2, then we'll remove the head element. Here, after inserting 10, 100 and 20, if the priority queue size is 3, that means we require only the second largest element. 3 is greater than 2, then we'll remove the last element, remove 10. In here 10 will be removed, and after that 90 will be added to the priority queue. Then the priority queue size is greater than the 2, then the condition is satisfied. Now we'll remove the least element. Here 100, 20, 90, the least element is 20. 20 will be the removed. After that we have the 80, and we will add this 80 to the priority queue. Now the size will be greater than the 2. Then we will remove the least element. The least element is 80. Here 80 will be removed, and we have 100 and 90. This is the minimum priority queue. Then we will get the minimum value of the two values, that is 90. The second largest element will get this 90 using the priority queue. Here the time complexity equal to n into log of k. That means we'll go through the all the array elements of n size, but we'll keep the size as up to k. Up to k means what is the largest element we require. Till that time we will save the values. This time complexity is n into log k. Now we will look into the program how we implemented this in Java. In Java, priority queue we have a class. We need to create a priority queue object, and for each element in the array, we'll add this two element to the priority queue. If the priority queue element is priority queue size is greater than our required that kth largest element, then we will remove that element from the priority queue. and at the last, after the all the elements are walked through, then we will return the head of the priority queue, that will return our targeted element. Now I will run this program and check whether it is giving correct or not. Now I am entering the third largest element. Now the third largest element is 80. Here the input is 10, 100, 20, 90 and 80. In this, 100 is the highest, after the 90 and 80 is the third largest element. Thank you everyone.